Modbus RTU সেটিংটা আরেকবার দেখবে এখন। Modbus সেটিং এর জন্য আমরা যেটা ইউজ করছি সেটা হচ্ছে সিগন্যাল বোর্ড অর কমিউনিকেশন বোর্ড CB1241, যে বোর্ডটা হচ্ছে পিএলসির উপরে প্লাগ ইন করতে হয়। আমরা আরেকটা কমিউনিকেশনের জন্য ইউজ করে থাকি মডবাস কমিউনিকেশনের জন্য, সেটা হচ্ছে সিএম। তো সিএম আর সিবির মধ্যে পার্থক্য হচ্ছে দুইটাই হচ্ছে কমিউনিকেশনের জন্য একটা ইন্টারনাল বা এক্সটার্নাল প্রসেসর ইউজ করা হয়। তো যখন আমরা সিএম বা সিবি ব্যবহার করব তখন যেটা করতে হবে, মডবাসের যে টেকনিক্যাল লাইব্রেরিটা আছে সেটা ইউজ করার সময় আমার চেক করতে হবে যে আমি কোনটা ইউজ করছি। এটা জেনারেল মডবাস লাইব্রেরিও আছে, আবার হচ্ছে কমিউনিকেশন প্রসেসরের জন্য স্পেসিফাইড মডবাস লাইব্রেরিও আছে। সো বেসিক্যালি আমরা কমিউনিকেশন প্রসেসের জন্য স্পেসিফাইড মডবাস লাইব্রেরিটা ব্যবহার করব। তো আমরা যদি আমাদের প্রোগ্রামে আরেকবার যাই তাহলে দেখব যে আমাদের যেহেতু ল্যাবের পিএলসি, সেই পিএলসিতে আমরা একটা কমিউনিকেশন বোর্ড CB1241 ব্যবহার করেছি। সো হাউ টু কনফিগারেশনে আমরা পিএলসির উপরে অ্যাড অন হিসেবে দেখতে পারবো একটা মডবাস সিবি। ঠিক এখানে হচ্ছে মডবাস সিবিটা দেওয়া আছে, যদিও আমাদের এখানে অন্য একটা প্রোগ্রাম খোলা ছিল, তো আমরা জাস্ট সেটা রিপ্লেস করে এখন একটা মডবাস কমিউনিকেশন বোর্ড এখানে ব্যবহার করব। So what we can do is we can remove this and then we can add another communication board CB, which is here, I believe, yes, communication board. You can see point to point and CB1241. They might have different part number depending on the versions, or only one part number if they don't have any updated version over there. So I'll drag it on top of the PLC. That's it, nothing more. But just to get an insight, let's click on that CB board. Now you can see general information on that CB. IO link, it means port configuration setting. Here I can see baud rate is 9.6 kbps, parity none, data bits 8 and stop bit 1, which we call in short 8N1. 8 is data bit, N parity none, and 1 stop bit. Now this configuration is fixed here, which we can change using our blocks. So let's keep it whatever it is right now. Now the important thing is, if you go to the system constant, the name of the CB is local CB1241. So this value is very important because we are going to use the hardware identifier, which is the system constant for this module 273 in our program. Now for Modbus, we have two types of setting. First setting is to configure the Modbus port number, that means CB board. In that setting, basically we set baud rate, parity, bit number, and number of data bits. So these settings are actually fixed for a single port. What we change is the ID and the register address for the Modbus devices, but port configuration is kind of fixed for whole of the for the rest of the process. So that's why we keep this setting in a specialized OB, which will be called once for restarting the CPU. So when the CPU is started, it will be called once, and the configuration for the port will be transferred from CPU to that port only once So that is called configuration DB. So we call that configuration DB in OB100. OB100 is specified for startup OB. So during startup it will be called only once, and after that we have to use the other Modbus block for other configuration, and this will be changed as per our requirement on the go. So that will be used in another block which will be called periodically in the program. So let's get to that thing. So what we have is main OB. This is the different program. So I have to add one new block. That block will be startup or restart OB, or startup OB you can call it. You can see in the OB, you can see startup OB, which will be OB100. Actually this OB100 is universal for S7-1200, 300, 400 or other series of PLCs. Now we have to change the language to ladder, because this is the language we know right now for this training purpose. So let's make it OB100 startup OB and then create it. Now as the OB is created, we have to configure the port configuration block in this OB and transfer it when the CPU restarts. Now if you go to the instruction, in the instruction set you will find that there are different types of instruction sets: basic, extended, and then you have communication. So we are interested in communication block. In the communication you can see there are different blocks. S7 communication, you can find get put. This S7 communication is between two CPUs or between two S7 devices. So let's forget it right now. We'll go for communication processing or communication processor. Then you will see that in the communication processor we have two options: Modbus RTU and Modbus, that is version 2.2. Now to keep in mind that we are going to use this type of Modbus. If you click on this specified block, you will see this block, and this block is specially used for different firmware version, and this block is used for lower firmware version. But if you use MB.com load this one, the version 2.1, so I think that is upgrade capable. So if you use it, then the rest of the CPU can use it too. But if you use the updated version, then there is a possibility that lower version or lower firmware version CPUs cannot use them. So let's get back to our version 2.1. So this is the main communication module to transfer the port configuration to the CB board. So we'll drag it here, and then we have to create an instance DB for this one. So let's make it MB communication load DB1. Now if you have more than one communication processor, as you are using one CB board, you cannot use another CB. So what we have to use it CM board. So CM and CB all together. For each CM or CB, you have to drag and drop this block and define a specified DB number for this block, and do not mix the number DB number between the blocks. Okay, so we have to be very precise about that. So let's make it the first one for our communication board, as we can use only one communication board, so we don't have to use load 1 DB1 2 3 4. But if you're using CM, I think you can use 2 or 3 CM. If you're using 3 CM, then you have to use different DB number, like MB load 1 DB, MB load DB underscore 1 or DB underscore 2 and DB underscore 3 for the rest of the CMs. Now we are back in here. Now what we have to do is we have to request, when you make the request bool type of data true, then at that instance all the information that you have provided in this block will be transferred to that CM or CB. So this request will be run once, because this whole block will be running once when the CPU restarts. So we can make it just true. So it will be requesting when the block is called. Now the port number is the port number for the CB. CB, you remember the hardware identification number or system constant. You will find that this is port number. This is exactly the same port number we will be using here, because the port number we get it from that CB board. If you click on the CB, you will find that system constant, general, and now each time you call a CB or CM, this type of a system constant will be automatically created. You don't have to put any number or anything like that. You have to just check the number and then use it as per your requirement. So port number is defined. Now we have to define the baud rate. Right now we are using 9600. Sometimes, if you are using, depending on the type of blocks you are using, this baud rate you can define in 9600 or in array like 0, 1, 2, 3, 4. For 0 it might be 9600, for 1 it is 19.6, so on. So for this specified block, they use exactly the baud rate without any array, so I'm using it there. Now the parity is 0 means none, let's keep it that way. Now this block will transfer the whole information from PLC to that CB board. Now the CB will try to communicate with the other field devices and fetch the data from the device and put it somewhere. That somewhere means you have to connect this Modbus to a specified DB or a specified location that the data fetched from the device will be stored on that location. So when you get there and read the location data, you will find the variable data in there. Okay, now we don't have any location for this one, so what we have to do is first we have to go to our main program. We have to call a Modbus DB. That means that is specified for getting information from the registers. So what we have to do is communication processor Modbus, and then we will use Modbus master, as we are collecting data from the devices in the field. So we are master here. We will be sending request and the device will oblige. Now we'll pick it here, and for Modbus master we will define an instance DB like Modbus master DB, and then we will be using like if the memory bit is like a clock bit 1 Hz, so we will be sending request every second. So let's make it clock 1 Hz, and then Modbus address of the slave address actually. So let's make it 1 for the slave address, and then mode make it 0, and then data address 40,000, or you can make 4001. Data length, let's take we'll take 3 data, and then pointer address, which is really interesting. For pointer address you have to put address like pointer. So for this operation, what we do is we'll just use 3, as we are getting 3 data from the field. What we can do is we can use MB data 40,001, okay, and then MB data 40,002. Sorry, my mistake. That should be MB data 40,003. So these are the data we will be looking forward. I think B is not working, however. So we are collecting data from 3 registers in the field, and those 3 registers data will be saved in this location. So pointer starting should be MW108. Okay, so to write the pointer address, we have to write in a different way. Like for pointer in Siemens, you have to write P hash and then M 108.0 3 by 6. Okay. So that means from M108.0 specific bit, from the single bit address 108.0, we are hoping to get data for next 6 bytes, which is 3 word data, that means 3 integer data. So that is the configuration right now we have. So this MB master DB is important because we are collecting data from CB board and we will be saving the data in this data block. So we have to put this data block in the specified CB. So here you have to use that data block like Modbus DB. That's it. No dot, nothing. So that's the configuration we are looking for. So after this configuration, our program is ready. What we have to do is we have to download the program in the PLC and install the PLC and start it again. And yeah, that way you can collect data from the field. Thank you.